Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 104 and the question is 11. It reads, a man can swim at twice the speed of the flow of a straight river. At what angle with the bank should he head upstream in order to end up going in a straight line across the river? So the first thing we should do is sketch the motion. So we draw our y and we draw our x axes, which make our xy or Cartesian plane. I'm going to draw the bank in dashed red line as normal. And we know that the river is flowing in a positive I-hat direction. And we know that we want to go straight across the river. So I'm going to say V man. So I want to actually go straight across the river. So if somebody was observing, for example, in a helicopter above the river, he would see the man go straight across. So what the man actually does is Vm, and that is to go straight across. And we all know, of course, that in order for us to go straight across, whereby a river is flowing to the right, we must actually angle ourselves. We should try and swim, we'll say, up to the northwest, and in actual fact that will end up us pushing to the right, or pushing forward, straight up, we'll say. So let's just analyse the following. If we said the velocity of the man relative to the water, and we know what that is, of course, it's Vm minus Vw. Now, because we're not given a stationary frame of reference, we can't use a stationary frame of reference, of course. However, we do know that the velocity of the man is twice the velocity of the water. So the velocity of the man is going to be straight up. It's going to be straight across the river. So it's just going to be in the j-hat direction. And the velocity of the river is just in the i-hat direction. So what we can say is this. We can say, if I call x the velocity of the water, we'll say this is going to be plus x i-hat. And the velocity of the man is going to be 2x j-hat. And that's going to be the velocity of the man relative to water. Alright? And that means the velocity of the man relative to the water, which is where he actually heads, is going to be negative x i-hat plus 2x j-hat. And the question is, does that make sense? Well, the first thing is, it says it's negative i-hat, positive j-hat, which puts us in this quadrant, as we thought it would. And the second thing is this. If the stream is only flowing in the positive i-hat direction with x, well then in order to cancel it out we need to go in the opposite direction with the same magnitude, which is what we have. So essentially by doing this, what he does is he cancels out, they will say, the lateral movement, so he can just go straight upwards, which makes perfect sense as well. And we're asked to find the angle with which Vmw gives against the bank. So let's just do this. We'll draw the vector. This is Vmw. We'll resolve it into its component unit vectors and call this angle here theta. This is Vmw sub x. This is Vmw sub y. Or we'll say j-hat and i-hat, like that. Alright, and these are of course at right angles and they're in those directions. So tan theta, as normal, is equal to Vmw over Vmw's j-hat over Vmw i-hat, and that turns out to be 2x over x, which is equal to 2. So therefore the inverse tan of that turns out to be approximately 63 degrees. I'm just going to do that in front of you. So shift tan for inverse tan of 2 is equal to 63.4 degrees. And the book actually says 60 degrees. And while I am open to correction, and absolutely, I may be incorrect, I think that that's actually a typo in the book, because just to we'll say to concrete this, or to really back it up, if we want to know that the magnitude of the x component of Vmw is the same magnitude as the water going in the i-hat direction. So if this was theta, and the magnitude of Vmw was root 5, alright, which is, that's what it is here, then it's going to be, this is going to be root 5 cos of, we'll say, 63, and that turns out to be 1, which is exactly what this is, which is x, 1x. Alright, so yeah, that's all I've got to say about that. Thanks for watching. Please pass it on to your friends and subscribe to my channel.